Guys, welcome to chapter 7. Today we're going to start off by talking about adding and subtracting polynomials. So before we jump into doing a few examples, it's important to have some good terminology down. A monomial is simply a polynomial with one term. An example of that might be something like 4x cubed. Another monomial would be just the constant number like 5 with no variable. A binomial has two terms. Terms are separated by addition and subtraction signs. So an example of a binomial might be 2x minus 3. A trinomial now has three terms, and therefore there's going to be three separate terms that are separated by addition and subtraction signs. So an example here might be something like x squared plus 4x minus 5. And finally, a polynomial is anything with four or more terms. So here's an example, x cubed plus 2x squared minus 7x plus 3. All right, let's jump in and get some more terminology with this first example. Here we want to use a polynomial and label the leading coefficient, the degree, and the constant term. As you can see, this is already written in standard form because it goes from the highest degree down to the lowest degree. This constant term right here at the back has a degree of 0, and that's why this is our constant term. Another thing to look at is this first term. This first term is going to have our leading coefficient, and that leading coefficient is simply the number that's in front of the term with the highest degree. And that leading coefficient there is 2. And the degree of that polynomial is the exponent on that first term, and it is the degree 3. So the degree of this polynomial is 3. It has 4 terms. That makes this just a polynomial. And the constant is positive 12. All right, let's jump into the heart of this unit, which is really talking about adding and subtracting polynomials. When we add polynomials, all we're going to do is drop any of the parentheses and combine like terms. Remember, a like term has the same variable to the same, has the same variable to the same degree. And therefore, when we add those terms, we will add the coefficients. Likewise, when we subtract polynomials, what we need to do is we need to make sure that subtraction gets distributed to that second polynomial. And the way that we can do that is we can make sure that all the signs after the subtractions change to their opposite sign. And then we'll combine the like terms and simplify. All right, first of all, we're going to find the degree of each one of these monomials. Now, finding the degree of a monomial means we need to add up all of the degrees of any variable in that single term. So this first degree of this monomial here is 3 because that's the only variable we have. In the second one, we have an x to the first power and a y to the fourth power, so the degree of that monomial is 5. In letter C, we have x squared and a y to the fifth, so we're adding those degrees. The degree of that monomial is 7. And finally, the degree of this last monomial is a constant. Remember, constants have degree that's equal to 0. All right, example 2, we're going to write the following polynomial in standard form. Remember, that's highest to lowest degree from left to right. Then we're going to give the degree and the leading coefficient. All right, standard form. Here we go. Negative x cubed plus 4x plus 15. Notice that that 15 is positive. There's no negative sign in front of it. The x cubed is negative, and therefore the leading coefficient is that number in front of that x cubed, and that's negative 1. And the degree of this polynomial is 3. All right, flipping the page over here to example 3. It says to write each polynomial in standard form, identify the degree of that polynomial, and classify the polynomial based on its number of terms. Our first example here is negative 4x cubed. It's a single term. It's already written in standard form for us. Its degree is the highest exponent sum here in that term, which is 3. The leading coefficient is negative 4, and this is a monomial because there is one single term. All right, our next one, we see that we have a little reordering to do to write this in standard form. So we're going to write it from highest degree to the lowest degree. That's 3x squared minus 2x plus 4. The degree of this trinomial is going to be 2. We do not add exponents across multiple terms. We only add the exponents in single terms. And therefore, this is a degree 2 with a leading coefficient of 3, and we said it was 3 terms. It's a trinomial. All right, our next example here, we have 4k cubed minus 6k to the 5th. So writing this in highest exponent first gives us negative 6k to the 5th plus 4k cubed. All right, the degree of this binomial, there's 2 terms here, is going to be degree 5 because that's the highest term degree. Its leading coefficient is negative 6, and we said this has 2 terms, so it's a binomial. All right, moving into example 4, we are going to now combine or add polynomials. Recall that when we add polynomials, we are simply going to drop the parentheses and combine like terms. So I could essentially rewrite this as one big long addition problem. 2x cubed minus 5x squared plus x plus 2x squared plus x cubed minus 1. All right, let's go through and combine like terms. I'm going to start with my highest degree, which is x cubed. I see I have a positive 2x cubed and a positive 1. That gives me 3x cubed. Next, I'm going to move down to my next highest degree, which is the squared terms. Negative 5x squared plus 2x squared gives me a negative 3x squared. Next, I have an x. That doesn't combine with anything else, so I'm just going to write it as positive x. And finally, my constant term of negative 1. And here's the sum of those 2 polynomials. Let's do the same thing for example B, 3x squared plus x minus 6. I'm going to drop the parentheses of this second one now. Plus x squared plus 4x plus 10. All right, being careful to combine just our like terms, we're going to combine the 3x squared and the positive 1x squared to get positive 4x squared. Next terms are my x's. I have a positive x and a positive 4x. That's going to give me positive 5x. And now I have a negative 6 combined with a positive 10 to give me positive 4. If you like this method of crossing off your terms so you can make sure you don't miss any, then I highly encourage you to use that. All right, our next example is where it gets a little bit tricky. When we're going to find the difference, we're going to subtract polynomials. What we need to do is make sure this subtraction sign gets distributed to each of the terms in the second polynomial, which means each one of their signs will change. So what we're going to do is we're going to change this to addition of the opposite polynomial. Watch how this goes. We have 4n squared plus 5. Nothing changes with the first polynomial. Now I'm going to change this to addition, and I'm going to change each of the signs of the second polynomial. So this becomes a positive 2n squared, and now it becomes minus 2n, and then it becomes a positive 4. So when we distributed that negative to all 3 terms, it changes the sign of all 3, and now we're going to combine like terms. 4n squared and 2n squared gives me 6n squared. Negative 2n does not combine with anything, so I'm going to drop that down to just minus 2n. A positive 5 and a positive 4, gives me a positive 9. And here is the difference of those 2 polynomials. Let's try it again with example B. When I distribute this minus sign to the second polynomial, it will change all 3 signs. Nothing changes with the first one, so we're going to just drop down all 3 terms. And now we're going to change this to an addition of the opposite. So this becomes minus 4x cubed, and then plus 8x squared, and finally plus 2. Okay, combining like terms, we have a positive 2x cubed and a negative 4x cubed. That results in negative 2x cubed. A 5x squared and an 8x squared is positive 13x squared. A positive 8 and a positive 2 is positive 10. And that's our constant term. And there is the difference of those 2 polynomials. All right, in our last example for today, we have a little word problem. And that word problem is going to tell us what we need to do with our two polynomials. It says we have the height of a red water balloon can be modeled by the following polynomial, and the height of the blue can be represented by the following polynomial. What is the polynomial that represents the distance between the heights of those two balloons? Well, when it says distance, distance implies the difference. We would always subtract to find the distance between any two polynomials. So subtract these two polynomials and come up with the distance between them, and we'll discuss that in class tomorrow.